All right, so today we're going to be talking about adding and subtracting rational expressions. It can be a little bit more difficult than just simply multiplying and dividing rational expressions, because again, just like when we add or subtract fractions, you have to have a common denominator. So to kind of warm up with, if we review how we added 1/4 and 7/12 together, what did we have to do? Well, we had to multiply the first one by 3 over 3. Okay, well, why do we have to do that? Other than just simply getting a common denominator. Well, if we look at the factors of 12, okay, so some of you might be thinking, okay, well, you just have to multiply 4 by 3 to get 12, and then they're the same. Well, yes, that's right, but if we just break it down even easier than that, 12 is simply 3 times 4. Okay, well, so this fraction over here already has the 4, and that's why it needs the 3 in order to have the same denominator. So yeah, we would end up multiplying by 3 over 3 on that first fraction there. So now we have 3/12 plus 7/12. And then again, when you add fractions, you add the numerators and leave the denominator alone, 10/12. And then you would factor and reduce. Well, 10 is 2 times 5, and 12 is 2 times 6. So again, you would cancel those factors out, and you would be left with 5/6. Okay, so that's the process that we need to understand from today when it comes to adding these more complicated rational expressions. You need to first factor to see what you have. That tells you what you need to multiply by so that you do have the same denominator. And then when you rewrite it with the same denominator, add the numerators, leave the denominators, and then if possible, factor again to cancel and simplify to lowest terms. Okay, let's see what that looks like. If you have x over x minus 1 plus 2x minus 1 over x squared minus 3x plus 2. Looks super complicated, right? Well, not as bad. Okay, again, focus on this denominator right here. Let's factor it. Okay, what are the factors of positive 2 that make negative 3? Well, that would be negative 2 and negative 1. So that's actually what this denominator is. Okay, x minus 2, x minus 1. Now, if you think about it in terms of the basic fractions that we had up there, this fraction over here already has x minus 1. So it needs x minus 2. So that's what we're going to multiply this first term by, is x minus 2 over x minus 2. Okay, a form of 1, so that we're not changing the value of the fraction at all. Okay, so when we do that, leave the denominator alone. Okay, so I rewrite this. I still have x minus 2 and x minus 1 now on the bottom. Okay, if I multiply this x by this x minus 2, you would distribute. So you'd have x squared minus 2x. And then you just rewrite what, we didn't do anything to the second fraction here. So 2x minus 1 over x minus 2, x minus 1. Now again, look at what we have. Okay, we have the same denominator. Just like up there when we added the fractions together, you add the numerators together and leave the denominator alone. Okay, so add the numerator together. X squared, you don't have any other x squared terms. Okay? You have a negative 2x and you have a positive 2x. Those actually cancel each other out. Okay, so those are gone. And then plus a negative 1, so that's just minus 1. Over x minus 2 and x minus 1. And just, okay, before we do anything else, it also says up here to include restrictions. So we can't have x is equal to 1 or 2. Okay, because if you set those equal to 0, that's what we would have, 1 or 2. You plug those in, you are dividing by 0. You can't do that. Okay, and then, again, like I said, factor the numerator again to see if anything cancels. In this case, you have difference of perfect squares. So that's actually x plus 1, x minus 1, over x minus 2, x minus 1. And wouldn't you know it, the x minus 1's cancel, leaving you with x plus 1 over x minus 2. And that would be your final answer there. Okay, so that's the process that's the process that we have to do here. Okay. If you want to try the second one first, go ahead. Again, factor first. Otherwise, okay, if we look at this one, x minus 1 doesn't factor at all. X squared minus x does factor. You can actually take an x out of both terms, leaving you with x times x minus 1. Well, the first fraction has x minus 1. It needs x. That's it. So you would multiply both the numerator and the denominator by x. So again, leave the denominator alone. Leave it as the two factored forms, x times x minus 1. But we have to simplify the numerator. So distribute the x, so you have x squared plus x. And then we didn't touch the second one at all, so you just rewrite what we have. Okay, again, when you do have the common denominator, add the numerator, leave the denominator alone. So you still have x times x minus 1 in the denominator, and then add the numerators. There's no like terms here, so it's just x squared plus x minus 2. Okay, before you cancel, list the restrictions. X can't equal 0 from this one, and x can't equal 1 from this one. Okay, factor the numerator. The factors of negative 2 that make positive 1 are positive 2 and negative 1. So that's what we have. And again, you see the x minus 1's cancel because they're the same factor. So our final answer would be x plus 2 over x. All right, that's adding. Subtracting is no different, except I do want you to do one thing first when you do that, and that is simply change this to the plus sign and distribute the negative to the numerator of the second one. Okay, so this was, like it down here, this was a negative. We're subtracting the entire second fraction. You're going to make it a plus sign and then distribute that negative to both terms in the numerator. Okay, so this would become a negative x, and this would become now a negative 2. Okay, and then it's just what we did before. Okay, factor the denominators right away. Okay, over here, x squared minus 2x. You can take an x out, so x times x minus 2. 2x minus 4 looks a little weird, but you can take a 2 out of both terms. So you have 2 times x minus 2. All right, so now looking at the denominators, right, they both have an x minus 2. Okay, so that's good. But this one has an x and this one has a 2. Okay, so the common denominator would include both of those 2 and the x. So this one over here needs a 2. So you're going to multiply by 2 over 2. This one over here needs the x because it doesn't have the x. So you have to multiply this one by x over x. Okay, so when we do that, again, multiplying the numerator, distribute the 2. So you would have 2x plus 4 in the numerator, and then just leave the denominator, 2 times x minus 2. And make it a plus, okay? Distribute this x, so you have negative x squared minus 2x over 2 times x minus 2. Okay, we want to simplify that into one fraction, so combine them by adding the numerators together. You have negative x squared is your highest term. You have a positive 2x plus a negative 2x, so those cancel each other out, and you're left with a positive 4 over 2 times x minus 2. And you might think you're done. You're actually not. If you look at the numerator, it kind of looks like difference of perfect squares, but it's not until you recognize that you can actually factor a negative out. If you take this negative away from the x squared, that turns it into a positive x squared. Well, if you factor the negative out of the positive 4, it becomes negative 4. And now all of a sudden this x squared minus 4 is x plus 2 and x minus 2 over the original denominator, 2 times x minus 2. before you cancel. It doesn't say up here, but we want to include those restrictions. X cannot equal 0 from this one and 2 from this one. And then notice how we can cancel the x minus 2's out, leaving us with negative the quantity x plus 2 over 2x. You could go ahead and leave it like that. All right, and then finally, last example. Again, go ahead and try it on your own if you want to. Pause the video, try it. Otherwise, I'll walk you through step by step. Okay, very first thing you need to do with these subtraction problems is distribute the negative, change it from a minus to an addition problem. Okay, so distribute that negative 6x plus 7 now. Okay, and then it's just like normal. Okay, you factor the denominators. The only one that factors is this one. Factors of positive 2 that make negative 3 are negative 2 and negative 1. Okay, so this one has a negative 2. It needs a negative 1. So that's what you're multiplying by, x minus 1 over x minus 1. Okay, you're going to have to FOIL on this side over here, but again, leave the denominator. X minus 1, x minus 2. Okay, when you FOIL that, maybe you need to do this off to the side here. X minus 1 times x plus 3. Okay, you get x squared, you get 3x, you get negative 1x, and you get negative 3. Those combine, so you're left with x squared plus 2x minus 3. Okay, plus, and then their second term, or the second fraction, we didn't touch at all, other than distribute that negative sign in the numerator. So just rewrite that. Okay, same denominator, so you combine them. Combine the numerators. Nothing combines with that x squared. 2x minus 6x is negative 4x. Negative 3 plus 7, positive 4 over x minus 2, x minus 1. Okay, include restrictions before you cancel. X can't equal 2 or 1 from the denominator. The numerator does factor. Okay, factors of positive 4 that make negative 4 would be negative 2 and negative 2. So you have x minus 2 over x minus 2, x minus 1. Cancel, cancel. X minus 2 over x minus 1. And there you go.